Section 3.5 is on piecewise functions. My nephew, who's taking Math 151 at GCC this semester, oh, he struggles with these. And I'm not sure why, but he keeps asking me the same basic question over and over and over. Maybe like 5 times this semester. His teacher does a lot with piecewise functions. Me, not so much. We'll just do the one section on them. So the function in problem 2 is broken up into pieces. There's two pieces. The top piece is x minus 5. The bottom piece is 2x minus 4. When I'm asked to change the x into a number, the number that's given to me is going to tell me which function to plug which level, the top or the bottom level, do I plug the number into. In this particular case, this number, the top one, I'm going to plug in any number that either equals 5. So if I get 5, I'm going to plug it into that because of the or equal to part of that inequality. And any number that's less than 5. If I'm asked to plug a number in like 5, which equals 5, like 4, which is less than 5, like 3, which is less than 5, like 0, which is less than 5, like negative 6, which is less than 5, if I was asked to find f of negative 6, or f of 0, or f of 3, or f of 4, or f of 5, I'm going to use the top level and plug the x in for the 6 in the x minus 5. Because the instructions say any number that's equal to 5 or less than 5, if you're going to plug it in for x, you need to plug it into the top choice. The bottom choice, the 2x minus 4, I would only plug in values that are strictly greater than x. So any number that's strictly greater than x than 5, because this says x is greater than 5, any number that's strictly greater, not equal to 5, I will plug into the bottom function. If I'm asked to find f of 7, I'm going to plug that x into the bottom function because this 7 is bigger than that key number 5. Similarly, if I was asked to find f of 5.23, I'd plug the x into the bottom number because 5.23 is bigger than 5. So what I'm going to do is for each of the problems for number 2 is I'll look at the number and it will tell me whether I'm going to use the top function or the bottom function relative to this. This rule right here says for any number that's equal to 5 or less than 5, plug the x into x minus 5. If you're given a number that's bigger than 5, plug the x into x minus 4. So when I look at this problem part A, I look at the number 5. If the number I'm given is 5 or bigger, I'm going to plug it into the x minus 5 function. If the number I'm given is strictly, whoops, I'm messing up there. Sorry. For part A, for f of 0, what this function says is if I'm given a number that's 5 or less than 5, I'm going to plug into the x minus 5 function. If I'm giving a number not equal to 5, but strictly bigger than 5, I'm going to plug the number in to the 2x minus 4 piece. When I look at part A, I'm asked to find f of 0. If I consider this a number line, 0 is about right here on the number line, and I'm going to plug the x into the x minus 5 function because 0 is in the band of x is less than or equal to 5. So f of 0, I'm just going to change that x to 5 and get f of 0 equals negative 5. For part B, to find f of 5, I already know where 5 is on my number line. When I'm given a number that's kind of the boundary, 5 is included in both the top function and the bottom function. When you're asked to plug a number in that's on the boundary, you need to pick the function that has the or equal to. The bottom doesn't have the or equal to with its inequality. The top does have its or equal to with the inequality. When I do this, I also have to plug into the top function. The solid circle means I'm plugging that number into that function. The open circle means at that function I'm ignoring that number. So this is going to be 5 minus 5. And my answer to part B, f of 5 is going to be 0. For part C, I'm asked to plug in 6. 6 in terms of a number line is to the right of 5. And any number that's to the right of 5 is going to go in the 2x minus 4 function. So I'm going to say f of 6 is 2 times 6 minus 4, which is 12 minus 4. My answer to part C is going to be f of 6 equals to 8. I don't have to write the function with my answer. For part C, if I just wrote the number 8 for my answer, that would be fine. Similarly, for part B, I don't really need to write f of 5 equals 0. If I just wrote 0, that would be fine. Also for part A, instead of writing f of 0 equals to negative 5, I can just write negative 5 for my answer. So the battle here is just figuring out what level of the function you're going to plug into. And sometimes there's 3 levels. Well, there could be 10 levels. 2 levels are easy. 3 levels, not so much, but that's what 4 wants me to do. Let me try to analyze 4. So in number 4, the key numbers I need to worry about are 0 and 3. If I'm given a number that's less than or equal to 0, so solid circle on the 0, and anything to the left of 0, if I'm given any number that is equal to 0 or less than 0, I'm going to plug in the function into 2x. If the number is between 0 and 3, not including 0, but are including 3 because the 3 has it or equal to, I'm going to plug it into the x function. Solid circle means I'm plugging it into the function on that line. Open circle, I'm not plugging it in. The last one, if I get a number bigger than 3, which is to the right of 3, I'm going to plug the function in for negative 5x. So each one of these parts of question 4, let me autofocus, see if it makes any difference. Give me a number and I have to decide where to put it in. So for part A, the number it gives me is 0 in the parentheses. I know I'm going to plug that into the 2x function because the 2x is what I put a solid dot for because of the or equal to. So g of 0, I'm going to plug into the 2x function. It's going to be 2 times 0, which is just 0. When I go to write my answer for 4a, I could write g of 0 equals to 0. That's kind of the nicest answer. Quite honestly, I don't always give the nicest answer when I'm writing my stuff up. I could just write 0. The next number I need to evaluate with is 3. On a number line, 3 is here. And I carefully, when I wrote this, I made an open circle on one of the 3's because that didn't have an or equal to, a closed circle on the other 3 because that had an or equal to. If I'm given the number, I'm going to plug it into the one with the or equal to. So the function g of x that I'm going to use here, I'm going to use g of x equals to x. To find g of 3, I'm just going to change that x to 3. My answer to part B would either be g of 3 equals to 3 or just the number 3. Part C gives me the number negative 2. On a number line, negative 2 is to the left of 0, so it's about there. The function I'm going to plug the negative 2 into is the 2x. So g of negative 2 is going to be 2 times negative 2. For an answer, I can say g of negative 2 equals -4, or I can just write the number -4. I guess I could even write y equal to -4 if I really cared to. Another three-layered function for number 6. Number 6 gives me a three-layered functions, and the key numbers that are mentioned are the numbers 2 and the number 4. The top function I'm going to use for any number less than but not equal to 2. So if I'm given a number that's strictly less than 2, open circle on the 2 meaning not including the 2, if I'm given a number like 1 or 0, I'm going to plug that number into the 2x squared minus 3 function. If I'm given a number between 2 and 4, including the 2 and including the 4, because I both have or equals to, I'm going to plug the number into the x squared function. And if I'm given a number bigger than 4, but not equal to 4, I'm going to plug the number into the 5x minus 7 function. So 2x squared minus 3 goes for any value of x that's less than but not equal to 2. X squared goes in for any number that's between 2 and 4, including 2 and 4. And I use the 5x minus 7 function for any number bigger than 4. First number I'm asked to deal with is 2. I go to 2, I look for the solid circle, so I'm going to plug it into the x squared function. So k of 2 is going to be 2 squared. For an answer, I can write k of 2 equals to 4, which is kind of the nicest answer, or I can just write plain ordinary 4. Now I'm going to do k of 4. I've identified 4 in my number line. I look for the solid circle that I created, and I'm going to plug 4 into the x squared as well, because there's where the or equal is. So k of 4 is going to be 4 squared, which is going to be 16. And for an answer, I could write k of 4 equals to 16, or what I'd probably naturally do, just write the number 16. Last thing I need to find is k of 5. I'm going to identify 5 on this kind of number line. Clearly, I'm going to plug into 5x minus 7 because that's the function that I use for numbers that are greater than 5. So I'm going to go k of 5 equals 5 times 5 minus 7, which is going to be 25 minus 7, which is going to be 18. So for an answer, I can say k of 5 equals to 18, or I can just write the number 18, and I'm completely content with that. Next few problems, we're going to graph these. I'm required to teach graphing piecewise functions. I will never ask you to graph a piecewise function on a test. This skill I might ask you. It's a moderately, minimally important skill. Graphing these to me, oh, I don't know. To me, it's not the most important skill, so I won't test on it, which means I'm going to teach you how to do it on your calculator. So let's graph a piecewise function and graph it on my calculator. My fancy new calculator does piecewise functions better than my old calculator, but I think I can do the piecewise functions the same on each and not do the fancy way. Let me see if I can make both calculators work exactly the same way so I'm not teaching two separate strategies. So what I'm going to do is enter the top function in y1, the bottom function in y2 on both of my calculators. So I turn my calculators on, hit the y equals buttons for both of them. Clear out any functions that are in there. Top function on both of them is x minus 5. If I'm graphing a piecewise function, I should put the function that I'm graphing in a parentheses. Now I need to tell my calculator I'm only graphing x's when they're less than or equal to 5, and I'm going to do that with another parentheses. So to get this part put in, x is less than or equal to 5, I need to, on both of my calculators, do parentheses, x, and now I need to say less than or equal to 5. It's pretty easy to find that. If you hit the math key, or is it the test key? If you hit second in math, you get the test key. Second button in the math key, you get the test key. And here I'm looking for the less than or equal to. So I'm going to scroll down to the less than or equal to and hit enter. Probably could just type the number 6, but I like scrolling and entering. And now I'm going to type the number 5 and close off my parentheses. There's the first function written perfectly. If I graph this right now in my calculators, I don't know what my windows are, and do zoom standard, it will draw a line, and it's going to stop when it needs to stop. It stops when it gets to x equal to 5. That's the first half. I could put this on my graph paper right now, and maybe I'll do that to get this first part done. So for this first part, it's a line. I need 2 points. Let me get the boundary point by going second in table and finding the boundary number 5. So here's 5, there's 5. Next to 5, I want to write the number 0. So part of what I'm going to graph is the point 5, 0. And then I need one more point. How about I plot the point, I don't know, 0, negative 5. I could actually plot 4, negative 1 if I care to. How about I do 5, 0 and 4, negative 1? Connect them with a line. I have to be careful at that point 5, 0 if I put the appropriate kind of hole. If it has an or equal to, I get a solid dot. If it has not an or equal to, I get an open circle. So I'm going to plot the points 5, 0 and 4, negative 1 on a graph that looks like this. So, and the point 5, 0, because this has an or equal to, is going to get a solid dot. So that point right there, the point 5, 0, gets a solid as opposed to an open dot. Stole the 5, 0 from my calculator, stoling the graph from my calculator. I'm also taking the point 4, negative 1 from my calculator. That's definitely going to get a solid dot. It's only the boundary points that can get round circles. So there's the first function, graphed not particularly well, but this is the portion. This is the graph of x minus 5 when x is less than or equal to 5. The next piece that I draw, 2x minus 4, is going to lead off with an open circle at 5. I always got to get the starting point in. Let me get that graph in there and see what happens. To get this graph added, I hit my y equals button and I go down to y2. And the function I need to enter is 2x minus 4 in a parentheses because I'm putting a parameter. So 2x minus 4, 2x minus 4. That's my function. Now my parameter, I only want this for x greater than 5. So parentheses, x, parentheses, x, strictly greater than 5. Second in math, and find the greater than, which is option 3. And it has to be greater than 5, but not equal to 5. Close out my parentheses. Now I can hit graph. Whoa. Somebody, I don't know what's going on with this red here. Let me see what's going on here. Graph. Somebody messed up. I don't know what I did wrong. Y equals 2x minus 5. I'm not sure what happened here with my nice calculator. I don't know what this red part is, but it's not. It's garbage. I've never graphed a piecewise function on my color calculator, so maybe this calculator is doing it and I just can't see it. Anyways, this is the portion that I need to draw. It's going to start off with an open circle. Let me get the y value. It's a line, so I need 2 points. But I hit second in table and go down to 5, and that's not right. Second in table and go up to 5. That's not, oh, it's because it's not using that function. Let me, I'll have to do this by hand because I have the problem in properly. If I would have made this an or equal to, then it would have given me a good value here. Let me show you real quickly. If I got, No, let me not show you. That's getting too complicated. Anyways, one of the points I'm going to plot is the 0.68. In the second function, when you plug in 6, you get 8. The second function, really, you're not supposed to plug 5 into it, but I need to have 5 plugged into it. So I'm going to plot the 0.68, the 0.5 something, and that's something I'm going to do with a circle. I'm going to get this portion of the line with an open circle. So I'm dealing with this bottom line. I know I'm going to plug 6, 8 in, and I need to find 5 something with an open circle. So even though I'm not supposed to plug 5 into the bottom function because of the not or equal to, in order to get the starting point from my graph, I need to take that number and plug it in. So the starting point of the second graph is going to be at the 0.56. So this point up there is the 0.56. The next point I'm going to plot is 6, 8. And I'm just going to connect a line, and I will be done with this graph. So at 5 and then 6, I get an open circle because I don't have the or equal to. Here at the 0.50, I got an or equal to, because of the or equal to, I got a solid circle. And then 6, 8. And then just draw the line that my calculator gave me. Give me an arrow to signify that it keeps on going. Similarly, get an arrow there to simplify it keeps on going. That looks good, other than I don't know what this part is. It's disturbing, but it is what it is. But that's it for that graph. Never ask these graphs on the test, but I'm going to do 3 of them with you. 10 and 12 are trickier because they have this middle inequality that's nested. So for my first inequality in y1, I'm going to put parentheses 2x, parentheses x is less than or equal to 0. In y2, I'm going to put x plus 1. And this I have to do weird. My calculator doesn't know how to do this kind of inequality. I'm going to have to do this. I'm going to write 0 is less than x and x is less than or equal to 3. I'm going to have to do this half and then this half kind of weirdly. It's just a fluke of how the calculator is programmed. And then I'm going to do y3 equals to negative 5x, get x is greater than, whoops, and then parentheses, x is greater than 3. Let me do these one at a time, and maybe not even have all 3. I'll just do one at a time, so not to confuse this. So first one, y equals clear and clear. It's 2x, parentheses, parentheses, second test, whoops, I've back to there, y equals parentheses x second test. I had to go back to the y equals screen because I forgot my x is less than or equal to 0. Now let me sketch this graph. When I put the or equal to, I can get the boundary point. This business where it starts drawing a flat line is not correct. I just need this portion of the graph here. My other calculator could be doing this all the time, but since it's not color, I can't see that flaw. So I just need this diagonal part of the graph, and I need to get 2 points. I need the point that has an x coordinate of 0, and then maybe an x coordinate next less than 0. So I'm going to go second table. One of the points I'm definitely going to plot is the point 0, 0. The other point I'm going to plot is the point -1, -2, and I'm going to graph that portion of the line. So 0, 0, there that is. -1, -2, there that is. I put a solid block on the 0, 0 because it has the or equal to there. Done with my first, moving on to my second, and I'm going to type over the first because I don't think it's going to help me to have all 3. So let me do the second one. The second one I go x plus 1 parentheses, 0 second math is less than x. Now I have to find that and. The and is basically in the same place that the less than is in, except I gotta use one menu over. So to get the and part, I go second math, and instead of going to test, I bounce over to logic. And there's my and or more than that. And then and x is second math less than or equal to 3. So the diagonal line is what I'm shooting for. Those flat lines, I don't know what they are. That looks like it's the point 0.01 right there. And let me look at my table. I'd like to get a value for 0 and a value for 3. The value for 0 is not going to be right because I don't have the or equal to. But the value of 3 is going to be fine. On this second line, the one point I'm going to draw is 3, 4. So part of what I'm going to put in is 3, 4. And I need to get the 0 part. Maybe you can tell it looks like the point 0.01, and it really is the point 0.01. To figure out what the 0 comma point is, it's going to be open circle because I don't have the or equal to. I just plug 0 in for that x. I go 0 plus 1 and get 1. So the 2 points I'm going to plot for the x plus 1 is the point 0.1. And this is going to be an open and not a closed circle because I don't have an or equal to there. And then I'm going to plot the 3, 4, and it's going to be a closed circle because I have the or equal to there. So first point, 0, 1 with an open circle. Next point, 1, 2, 3, 4 with a closed circle. That's my next graph. And now I'm going to enter this. I'm going to have an open circle, and let me show you where the open circle is going to be. For this one, when I plug in 3 to this one, because this is the bottom number, I go -5 times 3 and get -15. The points, one of the points I'm going to need to graph for this next one is the point 3, -15, and I didn't even set myself up to succeed. My graph doesn't go down to -15. So let me get down here. -10, -12, -14, -15. I'm going to plot the point 3, -15, open circle because I don't have an or equal to. And I'm going to need to get another point from my calculator, connect it, and draw a line. These are all lines because there's no squares. So bottom one, let's get my calculator going again. Y equals, clear this function, enter negative in the bottom row of the calculator, 5x should be in a parentheses though, parentheses, -5x, close my parentheses, parentheses, x, second math is greater than 3. I'm not going to see the graph so nicely, I don't think, because it's way below my window. If I want to actually see the graph, I need to make my window go lower. Let me just change my y min to handle this -15. Maybe make my y min -20, just so I can show you. The graph actually shows up. It's going down that way. So one of the points I'm graphing is 3, -15. Next, I'm going to get 4 something by going to my table, doing second table, and next to 4, I'm getting -20. The 3, -15 I manually found. The 4, -20, I'm just going to estimate, solid circle on all points that aren't on the boundaries, and draw my line. One more of these to go through. We're at 30 minutes. Let's do 11 together. It means my window might not be good. Each part of number 11 is a parabola. I don't know if I'll get any of the vertices. So the top part of number 11, I'm going to put in my y1, x squared minus 2 parentheses. If I put x less than or equal to -1, which really isn't correct, it'll allow me to get the points from my calculator. When I put the less than without the or equal to, it doesn't allow me to get the points on my calculator, and the graph's going to look exactly the same. My calculator is not showing any open or closed circles anyways, so I'm cheating right now. It's not technically right, but it's calculator friendly. I'm tired of doing these y's by hand for the boundary points. If I put or equals to, I'll get the same graph. It won't look any different. I'll show you in a second. So first graph, the function is x squared minus 2 parentheses x second test. I'll show you the difference. If I just do less than 1, well, if I could actually do less than 1, second test less than 1. If I graphed this, I might have a cruddy window right now. Let me go back to Zoom Standard. If I graphed this, I get this portion of the parabola that I want. And if I change this to do y equals, if I change this less than sign to a less than or equal to, the graph's going to look 100% the same. So if I go second math and change this to less than or equal to, on my calculator, because it's not showing the open and closed circles, it looks the same. But now I'll be able to get the points that I need. For this first one, I definitely want to plug the, I don't know if I did -1 here. Dumb. I did 1. Let me change this as a flub up. This right here should be less than -1. I messed up. Let me fix that now. So this is the graph that I want. It doesn't get the turn. So what points am I going to get? Well, I'm going to get the point -1 with, it's going to be graphed with an open circle, but I will find the point here in a second. And then one number less than -1. I'm not going to connect with a line, I'm going to connect with a curve. Let me do second table. Next to -1, I see -1. Next to -2, I see +2. And then I'm going to try to duplicate that portion of the parabola. So -1, -1, open circle on that point because I don't have the or equal to in problem 11. So first point, -1, -1, and then -2, +2, and then just draw something that looked like I saw on my calculator. Good enough for the beginning part. Middle part, I'm going to go back to y1 and type over. I'm going to write parentheses x squared, parentheses, -1 is less than or equal to x, and x is less than or equal to 1. Best I can, I'm going to get some points. I know for sure I need x, y values that match up to -1 and +1. Both are going to be solid circles. So on my calculator now, y equals, clear out, let's do this again. Parentheses x squared, parentheses, -1, second math is less than or equal to x, and then second math over to logic, and x is second math less than or equal to 1. Graph it. I need to get this put in, the curved part of it in, that little bit of the parabola there. Let me get some points by going to my table. Second table. Next to -1, I need +1. I need to plot that point with a solid dot. Next to +1, I need +1. It turns out that that point 0, 0 is going to be important because that's the vertex of this parabola. I'm going to put an extra point in to get that little loop. Everything's going to be solid dots. Both the -1 and the +1 are deserving of solid circles. So first point, -1, +1, solid circle. Second point, +1, +1, solid circle. And just to make this nicer, to get the curve in the parabola, I took the vertex of 0, 0 and snuck it in there. These I don't put on a test, so they're not terribly important. Last piece, I'm going to graph it with an or equal to just because I can get the y value that I need. So I'm going to do y equals x squared plus 2, parentheses, parentheses, x. I should technically just put greater than 1, but if I put greater than or equal to 1, I'll get the y that I want. This video's too long. So y equals clear, parentheses, x squared plus 2, parentheses, parentheses, x. Second, math, cheat and use a greater than or equal to. Graph will look the same and you'll be able to get your y's easier. Graph it. I'm going to need the curved part of the graph there. Go to my table, second table. I need the value next to 1, which is 3, and maybe the value next to 2, which is 6. So for this graph, I'm going to plot with an open circle the point 1, 3, with a solid circle the point 2, 6, and try to get something that looks like that. The reason this point 1, 3 gets an open circle because I don't have the or equal to. So 1, 3, open circle, 2, 6, close circle, finish off and draw the parabola. Sorry that this video is a little bit long. I just wanted to get it in without doing a second part. Don't ask the graphs of these piecewise functions on the test, but just in case you need to do them in another class, you have a tool.